This problem is another problem that focuses on Riemann sums, intermediate value theorem, extreme value theorem, mean value theorem. This is a no calculator problem, and our data is given in a tabular form. So let's take a look at this. Let f be a function that is twice differentiable for all real numbers. The table above gives values of f for selected points in the closed interval from 2 to 13. Estimate f prime of 4, show the work that leads to your answer. Okay, so f prime of 4 would be the derivative of f at 4. You notice we don't have a value for f at 4, but we have two values near it. So basically f prime of 4 should be approximately equal to the slope of the secant line using the points closest to when x is equal to 4. So we're going to take f of 5 minus f of 3 over 5 minus 3. So we have negative 2 minus 4 over 2, or negative 6 over 2, which is equal to negative 3. And we are not given units for that, so we don't have to worry about units. Let's take a look at the scoring for that part. The scoring for that part is simply your answer. I would imagine that without the work, you're not going to get credit for that, though. So make sure you show the work. In the next problem, part B, it asks us to evaluate the integral from 2 to 13 of 3 minus 5 f prime of x dx. Alright, so let's use properties of integrals here to split this into parts. So we're going to integrate from 2 to 13, 3 dx minus, we're going to take the 5 outside, the integral from 2 to 13 of f prime of x dx. Okay, so the integral of a constant, so we've got 3 times x from 2 to 13. We have to evaluate that. And 5 times the integral of f prime from 2 to 13. So that's going to be 5 times, using the fundamental theorem, f of 13 minus f of 2. Because when we integrate, we take antiderivatives. And the antiderivative of f prime is f. Alright, so here we are. 3 times 13 minus 2 minus 5 times f of 13 up at the top is 6 and f of 2 is 1. So f of 13 is 6, f of 2 is 1, and we need to simplify that. So 3 times 11 minus 5 times 5, and when we simplify that, we get an answer of, what do we get? 33 minus 25, which is 8. And we should check and see if we have any units for that. No, we do not have units for that. So let's take a look at the scoring on that. Scoring on that uses fundamental theorem of calculus, and you get an answer. I would assume that you don't have to simplify this, but you cannot leave these. You have to plug those numbers in. Alright, let's take a look at C. Use a left Riemann sum with subintervals indicated by the data in the table to approximate the integral from 2 to 13 of f of x dx. Show the work that leads to your answer. So, use a left Riemann sum. So we are going to form rectangles, and we are going to use the height of the function at the left-hand side of the rectangle to determine the value that we're going to use. And we're going to have 4 rectangles. So the widths of the rectangles are the difference in the x values. So a difference of 1, a difference of 2, a difference of 3, and a difference of 5. So our Riemann sum for that integral is going to be 1 times 1 plus 2 times 4 plus 3 times -2 plus 5 times 3. So in part C, the integral from 2 to 13 of f of x dx is approximately equal to 1 times 1 plus 2 times 4 plus 3 times -2 plus 5 times 3. And if you figure that out, you get 1 plus 8 minus 6 plus 15. Add all those together and you get 18. So let's take a look at the scoring on that. Uses a left Riemann sum and you get an answer. Alright, so we've got 5 out of the 9 points accounted for. Part D is a big one. It's 4 points. But remember, you get a little bit for each part. So even if you're stuck on it, do as much as you can. Alright, so there's a lot of information in part D. Suppose f prime of 5 is 3 and f double prime of x is less than 0 for all x in the closed interval from 5 to 8. Use the line tangent to the graph of f at x equal 5 to show that f of 7 is less than or equal to 4. Second part, use the secant line for the graph of f on the interval from 5 to 8 to show that f of 7 is greater than or equal to 4/3. Alright, so let's take the first part. F prime of 5 is equal to 3. We need to find the tangent line, so we need to find f of 5. Hopefully that's in the table up there. F of 5 is equal to -2. So we can write the tangent line, and that would be y minus -2, or y plus 2, is equal to the slope times x minus 5. And basically the idea here is that we are using the slope of the tangent line at 5, and our function is concave down. So basically here, sorry, not the slope of the tangent line, but the tangent line to estimate f of 7. So this point here would have a y value at f of 7, but we're going to use the y value from our tangent line to estimate it. So I like to use this notation. F of 7 is approximately equal to y of 7, which is going to be 3 times 7 minus 5, and then we're going to subtract 2 from that because we're moving this 2 over to the other side here. So we've got a value of 3 times 2 is 6, minus 2 is 4. So f of 7 is approximately equal to 4. Alright, but we also know that f double prime is negative on the entire interval from 5 to 8. So we have a picture that looks like this. Here's f of x, and here's the tangent line. We'll call it y. So we know that f of 7 is actually less than or equal to 4 because f is concave down on the interval from 5 to 8 because f double prime is negative. In the second part of this problem, it says use the secant line for the graph of f on the interval from 5 to 8 to show that f of 7 is greater than or equal to 4/3. So we're going to have to find the equation of the secant line. So the first thing we're going to have to do is find the slope. And the slope of the secant line is, well, let's see. I'm going to call it m. So it's going to be f of 8 minus f of 5 over 8 minus 5. So f of 8 is 3 minus f of 5, which is -2, so it's going to be plus 2 over 3. So we have a slope of 5/3, and we are going to again use the secant line to show that f of 7 is greater than or equal to 4/3. Okay, to wrap your head around this, I tried to sketch a rough graph of this. So our function goes from the point 5, -2 to the point 8, 3, and it's a continuous function. And what we're doing is we just found the slope of the dotted line, the secant line, and we're going to use the equation of that secant line to estimate the function value at 7 and see what we get from there. So the equation of our secant line would be y plus 2, I'm using the point 5, -2, is equal to 5/3 times x minus 5. And we're going to plug 7 in there, so f of 7 is approximately equal to y of 7, which is 5/3 times 7 minus 5 minus 2. And when you simplify that, you get 10/3, because 5/3 times 2 is 10/3, minus 2, which is 6/3, which is 4/3. And you can see from my picture that f of 7 approximately equal to 4/3 is an underestimate because the fact that the function f is concave down on that interval. So f of 7 is greater than or equal to 4/3 because f is concave down on the interval from 5 to 8. Therefore, because f double prime is less than 0. Alright, so let's take a look at the scoring on that. The tangent line you get a point for, estimating f at 7 using the tangent line, the secant line, and shows that. Interesting part about that is they don't ask for justification, but I think it's implied in this part right here. So writing the equation of the tangent secant line gives you 2 out of the 4 points. Even if you only got 7 out of the 9 total points on that problem, that would be great.